Hello, my dear students. Welcome back to the lecture. So in this lecture, we'll try to see what are the different ingredients, what is present in the cement during the manufacturing, and also what is Bogus compound. So this question you may or may not get. Sometimes when they try to ask more questions regarding to cement, they may ask you this question. And of course, maybe they may ask you even the Bogus compound also. But anyhow, we'll not leave this and we'll try to understand this. Okay. So first try to understand whatever I'm showing you here, right? So these are the ingredients, what is present in the cement. That is, these are the raw materials when you want to prepare the cement, right? So these are the raw materials that you require. So you require lime. So they may ask a question, what are the raw materials that is required for the cement? So you can say this is lime. After lime, you require silica, alumina, iron oxide, magnesia, sulfates, and alkalis. So these are the percentage what is required for the lime, silica, and all. So again, you don't have to remember everything, but the first two you try to remember. Lime will be added in the 62 to 67%. Even you can take 65%, you can tell, no issues. Silica, you can tell 17 to 25, even you can tell 20 to 22% is my silica. Alumina, you try to remember 3 to 8%. Rest all things you can tell a minimum amount has to be added, right? Now, one thing you understand here, in the initial lecture, I told you, if you take pure lime, what will happen? Pure lime is not going to set early. So you can see it here. And then I told you, when we prepare cement, what we do, we take lime only. For the lime, we try to add impurities. Now, if you try to observe the same pattern here, you see lime, we have taken a lime here in the cement. These are the raw materials for the preparation of a cement. You have taken lime, that is calcium oxide. But look at the percentage, 62 to 67%. If instead of 62 to 67%, if I take this 100%, what will happen? This itself is my pure lime. But if I take pure lime, what will happen? It's going to set slowly. So I don't want that to happen. So what I've done, I've taken 62 to 67%. That means out of 100, I've taken only 67%. What is the remaining percent? 33%. And what we are going to do with this 33%? So this 33%, what we are going to do is that we try to add impurities. Okay. We try to add impurities. And what are these impurities? These impurities are nothing but silica, alumina, iron oxide, magnesia, sulfates, and alkalis. So this is exactly the chemical composition of the cement. Now you might have got an idea what exactly was, if I don't add silica, alumina, iron oxide and all, this becomes my pure lime along with the lime, but I'll restrict the percentage to 62 to 67%. Rest 33%, I'll try to add all these impurities and then my cement is going to get ready. This much is clear. Yeah. Again, there is a lot of concept to this. I'll be not explaining it here because it's going to take a lot of time, but a small understanding I'm going to give you. It's already explained in my concrete technology course. So first, in cement, we try to manufacture cement in two ways. One is the dry method. The second is a wet method. They may ask even this question also. How can you manufacture cement? I'll take you to that slide. Yeah. So cement can be manufactured in two ways. One is your dry method. The second is the wet method. You can see it here, dry mix and the wet mix. We always go with a dry mix. Wet mix, we don't use it because wet mix, what will happen? It will take long time for the cement to come out and a lot of fuel is wasted there. High amount of fuel consumption will happen. So I don't want to invest so much of money for the fuel consumption. So we don't go with the wet mix. In dry mix, you don't have a problem of heating it for a long period of time. So dry method is a good method. And you can see here, dry method is a modern and widely used method. Okay. Okay. And all these things, if you understand from my course, it's well and good. It's not required, but always a good thing if you understand. They may ask you, can you explain the working of a dry method or something like that? Then chances is very less, but still, if you understand, it's well and good. Yeah. Now, in dry and wet method, which method is going to give you a good quality of cement? Of course, in the wet method, I'm going to get a good quality of cement. In comparison to the wet method, dry method, the quality of cement is little less. But when it comes to cost, in wet method, huge amount of cost is involved, whereas dry method is a bit cheaper compared to wet mix. So what we try to, what is that? Yeah, we try to go with a dry mix only even though we get a little less quantity of quality of cement is little less in comparison to wet mix. We'll try to add some other thing so that we can improve the quality. What this much is understood? Yeah. Again, you see how the cement is actually manufactured. When you try to heat the cement at a temperature of 1400 to 1600 degrees Celsius, these are the clinkers what is formed. Okay, so this clinkers after getting cooled down, no, they try to become something like this, and finally you can see a kind of this, these are called as granules or modules, you can call them, and finally you try to powder that. Okay, and finally you get a cement something like this. Of course after that you're going to pack the cement. Okay, so this is the history of cement, how it is manufactured and all. Okay, yeah. So about the wet method, I told you that, see, this is that wet method. In this you'll be having a 3 zones. Okay, that is, you have a dry zone, you have a burning zone, you have a clinker formation and all. So it is going to take a long time for you to for the wet mix to happen. So that is why we don't try to use the wet mix. This much is clear for you? Yeah. Other than that, yeah, this is enough for us. Other than that, one more thing you need to understand. I'll just pause my video here. You can note down this point. So I've explained all these things. See, here I told you that lime is there in cement, silica is also there, alumina, iron oxide, and magnesia, right? So what these people are going to do, what lime is going to do, what silica is going to do, what will happen if I add silica more than 25%. So all those I've given explanation here. I've explained it in my concrete technology course. You can learn from here, from there, but I won't be in a position to explain all these things in a short duration of a course. Again, it will become a lot of theory class. Okay, so I'll pause it here. I'll written it in a better way. You can take a screenshot and try to understand this. Okay, yeah. So again, iron oxide, this is the importance of adding iron oxide. Then this is the importance of adding magnesia, sulfates and all. Right? And of course, the alkalis, this is the importance of that. Got it? So try to note down on your own so you can understand all these things. We'll go back to the main agenda again. Yeah. Yeah. So this much is understood. Next, they may ask you a question about the Bogus compound. So in Bogus compound, we have 4 Bogus compound. The first is called as tricalcium silicate, C3S. Next we have C2S, that is dicalcium silicate. The next we have tricalcium aluminate, and then we have tetracalcium aluminoferrate. So try to remember the 4 name and also their formula of C3S, C2S, C3A, and C4AF. This is not required. This formula is not required. And if you can remember, try to remember this also. C3S we require in 30 to 50%, C2S 20 to 45, C3A 8 to 12, and C4AF is in percentage of 6 to 10. Okay, there are a lot of questions which can be formed, but this much you have to understand. There's no other way. Okay, there's no other escaping from this. And the one which is going to give us strength is actually the tricalcium silicate and dicalcium silicate. They are the people who are going to give us the strength to the cement, right? Yeah. So this much is understood. So yeah, again, when this Bogus compound is formed, actually when we take the raw materials, we're taking this as a raw material, and when we try to heat this particular raw material, they're going to fuse together, and finally when the cement is formed, no, in that cement we'll be having this Bogus compound. Whatever these things are there, whatever raw materials were added at different temperature, these raw materials try to combine with each other, and as a result of that, this Bogus compound are formed. So who is Bogus? Bogus is the person who first identified this particular compounds, hence we have given the name as Bogus to that. So tricalcium, dicalcium, tricalcium aluminate, and tetraaluminopherrate. This much you have to understand. Yeah. Then we'll go to the last another 2 questions we are there. So we are going to do the specific gravity test for the cement. Okay, because the specific gravity of a cement is 3.15. But how do you find that? And while finding, we make use of a kerosene. Like if I ask you to do the specific gravity test for the other particles, like for the fine aggregate and all, there we try to make use of water and all, right? But in cement we try to make use of kerosene. So what is the reason behind that? Yeah, the reason is very simple. If I try to do my specific gravity test along with water, then of course when the moment the cement comes in contact with the water, hydration is going to happen, and the main purpose is not served. I want to find the specific gravity. So that is why we try to make use of kerosene. Now, why kerosene? Kerosene only should be used. The specific gravity can be found by using water. But since cement reacts with water, so we don't use water and use other similar liquid like kerosene to get the specific gravity of the cement. So cement and kerosene will not react. So if they don't react, of course, the main purpose was to find the specific gravity, will be in a position to find the specific gravity. So this is a test we are supposed to do in the laboratory. So if you know this test, well and good. I don't think they'll ask you this question in the examination, how this test is conducted and all, but this question can be an interview question, that why do you use kerosene and not the water? Yeah. So I hope you have enjoyed it up to here. We were able to understand what are the raw materials present in the manufacturing of the cement. A Bogus compound is also a very important question. And then of course the kerosene question is also important, but try to understand or try to concentrate more on the box compound, and also about the ingredients present in the manufacturing of a cement, like alumina, we have lime, we have silica, then we have alkalis and all. And also try to understand what are the importance of those compounds, like what alumina is going to do, what lime is going to do and all, right? A one word answer if you have, that is always a good thing. So we'll see you back in the next lecture. Thank you.